Swayam Prabha. Digital India. Educated India.
Good morning to everybody and welcome to our course on Introduction to Mechanical Micromachining. In the last class we have started about looking at the aspect of different machining processes, and we have seen that how the location, that is the interface between the tool and workpiece, behaves when we do cutting at the micromachining or at a micro level. And here we have seen some of the size effects. Size effect means that when you scale down any system or any component, how does it behave when it is at a macro scale or bigger scale. So, what are the differences we have to look after, so that we can understand that process or the process mechanics much better way, and we can get the amount of required results very carefully, and other way it is important things. And we have seen one diagram. So, this is the first diagram we have seen in this case, and if you see this thing, we have targeted 4 locations. So, this is the location 1, that is the deformation zone, and we have seen that there is a slip band through which the material start deforming from the uncut chip thickness to the original chip thickness. And then there was another one, second one was the material deformation or the workpiece deformation, where what happens to this particular level, because this is the part which we have desired out of this machining process. So, is there any property difference in the material, or there are some other defects created because of this machining at micro scale? Those things should be discussed, or those things should be keep into mind to understand the machining at micro scale. Third one was the edge radius, and because of the edge radius we may encounter ploughing effect, which is not good thing for the cutting operation. And the last one was the location 4, that is the chip initiation region. So, when the sharp tool or the blunt tool interact with the material, at that time what happens, that it may create some type of chip initiation, because when it interacts at this particular location, at that time deformation may get started from some location, and then it will propagate to facilitate removal of the chip from the workpiece. So, these are some of the things which we have discussed in the last class, and then we have seen that what are the problems with the merchant theory, say application to the micro machining processes. And these are some of the things. The radius of cutting edge was very small compared to the uncut chip thickness, grain size is comparable with the thickness, rounding of the edge also create problem, grain size is also creating problem. So, those are things we had discussed in the last class in detail. And forces is also important thing, because forces will create a problem when you cut a machining, cut a material at the micro scale, chip thickness, chip formation, and this thing we had discussed. And then we have seen that in the micro machining, many times a single point cutting tool or the milling tool will interact with a single grain compared to the macro machining or the conventional machining, where the large number of layers of the grains may pull out or may come out as a chip, and it will not create any problem during the machining process. But here it is not that case, and you are end up with the machining or the cutting of a single grain, and then depends everything on the orientation of the grain and the distribution of the grains. And because of that, we have seen that there are large fluctuation of the cutting forces, because sometimes you may encounter a grain boundary. So, material removal will be very easy, and sometimes the grain is located exactly at the center of this particular thing. So, you have to cut the grain. So, at that time you have to apply more force compared to the cutting at the grain boundary. And because of that, the large variation in the cutting force, many times you are not able to do machining at a stable rate, and at the end your tool will be broken. And we have seen the what is the difference between the uncut chip thickness and the cutting edge radius, and because of this particular large difference, you are end up with a negative rake angle. Your original rake angle was positive, but when you cut with a size reduction, you are end up with the uncut chip cutting edge in a negative side. And these are the reasons what is going to happen because of the small chip thing is you have to reduce the chip load, and when you reduce the chip load, that means you have to reduce the depth of cut and your low productivity will be resulted in this case. And to encounter or to remove this particular thing, what you have to do, you have to operate a machine at a very high RPM, so that you can reduce the low productivity issues. And then we started with the 4 different mechanism through which the material flows, and that was based on the this cutting edge angle. So, back rake angle, or we can say the rake angle, or the orthogonal rake angle. There are many ways we can define this thing. And here what we have started learning, that this is the rake angle right now, it is very small in a negative side. Then we will see in the next class, in this particular class, that what happens when this S point is moved at a different location along the cutting edge radius of the cutting tool. So, this thing we have seen that it is the first phenomena we have encountered is the shearing. So, shearing is important and that is required to remove material in form of chip. So, here we have seen the material is removed in terms of chip here, but some of the material is also moves along the direction of the chip tool motion, and that will again squeeze, and then again it will become a part of the chip, and that happens in a subsequent processing steps. So, one after another sequence will occurs, and then it will remove the material in form of chip. So, we completed the shearing portion in the last class. Now, second one is the extrusion. Now, what is extrusion here? Because we know extrusion in the form of metal forming process, because in the metal forming what happens, that suppose you have a die and then you have material. So, this material will pass through this line, and then everything will be squeezed away, and then you will get the reduction in the diameter or the reduction in the area. So, this is the output and this is the input material and this is the die. So, what we are doing here, that we are extruding the material to reduce the area. Area may be radius or diameter also, or the cross section of any square section or rectangular section, whatever it may be. So, here the same thing is happening in this particular case here, because the material is extruding through this part and only small amount of part of this particular uncut chip thickness will come out as a chip, but remaining material will extruded through the material, extruded through the flank face, and then become a part of the machine surface. So, let us see that what are the reasons for happening this thing. So, when we reduce further HC to R, so now our HC is this one. So, this is HC, and whatever is this this is the R. So, what we are doing, we are reducing HC by R. So, your R is very larger than the HC. So, your uncut chip thickness small, but R is very large. So, here what happens, there exists a critical threshold of HC by R. So, this critical threshold is for what purpose? That is to form a chip, because ultimately in our machining part we need chip, because we want to remove some material from the workpiece, and if you do not get the chip, then you are end up with the losing the energy and all your required part in terms of just mechanical workout only, but not any type of actual working. So, because of that, you have to maintain this particular ratio in such a way that you are getting a chip, but not the just flow of the material or the displacement of the material from here and there. So, material is extruded at tool edge rather than shearing deformation. So, what is the shearing deformation? So, shearing deformation is a chip, and this material extruded part, this is the extrusion. So, ultimately you are not removing all the material from the HC, the part of this HC will go as a chip and remaining part will go as a extruded material in the machine surface, right. So, how you can understand this phenomena? This can be understood by a grinding process, because we know that what is the grinding. So, in grinding, so this is the grinding wheel, and very very small size abrasive particles are located on the periphery, and then when it rotates, at that time this is the workpiece, and when it rotates, and then what will happen? It will push the material in this particular zone. So, this particular zone is the plastic deformation zone. So, that is below the machine until a crisp. Now, how this particular thing will remove the material? That when particular grain will interact with the surface, it will create a plastic deformation zone, and that plastic deformation zone will enlarge, or it will continue to form or continue to enlarge in such a way that you finally you are end up with a one critical stress condition where the chip will be removed in form of a small fragment of the workpiece material. So, what we can do, that we can actually understand this particular phenomena whatever is happening in the machining in form of a grinding process. So, here also what we are doing, our depth of cut is very small compared to the machining processes in grinding, and similar way in micro machining also our depth of cut is small. So, it is not a very bad idea to understand this particular extrusion phenomena in the form of a grinding process. So, this is how it will it is happening in this particular case. So, it continuously deform the material, and then it will reach to one particular critical stress condition. Once it crosses this particular condition, at that time chip is produced through the micro mechanism. So, here in this particular case also you will get chip, but the chip may be smaller than the shearing mechanism, because in the shearing it is the size of the chip is bigger and it may be uniform also in this case, but comparatively this particular phenomena is also not suggested in the micro machining for efficient removal. So, what happens in this particular case? So, there is a abrupt change in the material deformation with material flow in the opposing direction of the tool. So, now we know that tool is moving in this direction and our objective is to remove that material, and now we know that this is the one particular zone through which the material deformation takes place. So, only small amount of material. So, this is our HC. So, you consider the small amount of HC part, this part, this part may go as a chip, and the remaining part whatever is here, this part will be extruded into the machine zone. So, this is the deformation of the all this material, this HC will be deformed completely, but it may not come out as a chip, but some of the part will be become a machine surface in terms of the extrusion process. Right. The small amount of material escapes as a chip. So, that is what is showing here, and the remaining deformed material is compressed by a lower portion of the rounded edge. So, what is the lower portion of the rounded edge? So, this is the lower portion of the rounded edge. This whole edge is rounded, but now we have divided this whole edge in terms of two parts. So, this is the upper portion and this one is the lower portion, and this is the E point, which is important to understand that this is the location through which you are end up with the two different phenomena, and you are getting a shear plane angle in this particular case. So, some material will escape as a chip, and while the remaining material is compressed by the lower part of this particular location, and then this material will be compacted back into the bulk material to form the machined surface. So, now where this material will go, because here you do not have any other thing. So, now whatever is part of this particular thing, this will go in this direction and this will go in this direction. Now, it will be compacted further. So, here it will be very compressed situation. So, in this case the property, the top whatever the surface property may also get changed. So, in this case if you are not required or you are not intended to get the change in the property, then this particular phenomena is also not advisable for the micro machining operation. Right. So, now third one is the ploughing phenomena. So, what is the ploughing phenomena? So, this is the ploughing. So, ploughing is the displacement of the work material by plastic upheaval on the machine surface at a higher negative rake angle. So, let us see each and every terms. So, we know what is the higher negative rake angle. So, this is the higher negative rake angle, because now if you see from this, now you consider in earlier case the point was somewhere here, that earlier point. Now, we are considering suppose your alpha, or that is the rake angle is extremely negative in this case. So, now your point, we are a point of concentration is the P point. So, this is the negative rake angle and displacement of the material by a plastic upheaval. So, now what is this thing? Plastic upheaval. So, this is the cut. So, now consider your cutting tool is something like this. So, this is your cutting tool and it is moving in this direction. Now, what we need, that we need a chip to make this particular thing efficient, but instead of chip what is happening here? So, whatever is this material, let me give this different color. So, this is the material which is displaced from this particular location, right, but it has not come out as a chip. So, where it is going, this material, some of this material will be displaced on both the sides and some of the things will create this type of bulging. So, this is the bulging of this particular part. So, once this bulging is sufficiently higher height, then what will happen? The some of the material will go in this direction and some of the material will go in this direction. So, that is given by these arrows. Now, if you follow these arrows, black arrows, then this is what is going to happen. So, this phenomena is called ploughing operation. So, now we know that if you continue your machining in ploughing region or in this particular ploughing mechanism, basically you are not removing the material, you are just moving material from one side to another side, and at the end what is going to happen, that once this path is over, then what happens, that you suppose want to remove some more material from here. So, your second path will be from this location. So, now your groove creation will be here. So, whatever material you are removing from here, some material will go in this direction, some material will go in this direction. So, basically you are displacing the material within the machined area. So, ultimately you are not getting any material removal out of this region. So, finishing of the machine surface deteriorate with ploughing, which also play a crucial role in the energy consumption. Now, you know in this particular case, now let us see what is going to happen. Now, if you see this cross section from here, now what is going to happen? So, this is your original surface, suppose, and this one is your tool. So, this is our tool. Now, tool is already penetrated up to this area. So, now this much amount of material, whatever is here, this much amount of material will be displaced somewhere. So, now consider this material is displaced in the side surface. So, whatever is here, so this is the ploughed material. Right. So, this is the this and this material, right. Now, this part is okay. Now, let us see that your tool is moving to the next location. Now, this part is over and our depth of cut is this much. Now, consider this is the depth of cut, and now we want to remove some material from here. So, again now see the how much amount of material we are removing from here. So, if you calculate this area, just a minute. So, now this is our tool part and this one let us call area A. Now, your tool is moving from this location to this location. So, now next location of your tool is this one. So, this is your next location of your tool, same depth of cut, but it is just moving to the next location. So, this is the next location, but problem here that some of the material from this particular part it is already piled up here, right. So, your tool now what is the area in this location? Now, area will be this much, this whole area will be removed by the cutting tool in the next operation. So, this is the area B. So, what is here that B is bigger than A. So, next case your tool may encounter more amount of material and because of that you have to spend more energy to remove that much amount of material, and it may continue because now whatever you are ending here. So, this much amount of material, some of the material will piled up here again, even though some material is removed here. So, it may fall down in this particular area also, and if you extend this workpiece then some material will be here also, and that is again called the plowed material. So, in that way you are actually wasting the energy without doing any efficient material removal from the workpiece. So, what is the final decision or the conclusion out of this? That plowing should be minimized to get the material removal. Now, what we do in the micro machining? The micro machining plowing effect cannot be neglected, because we know that whatever we do here you are end up with the negative rake angle. So, regardless of the nominal rake angle, whether you are positive, negative or the 0. So, what is the nominal rake angle? So, nominal rake angle what we are measuring is this one. So, this is your alpha, but when it removes the material mostly it happens in this region. So, this is your effective alpha, right. So, that is the negative part and this one is the positive. It may be 0 also. If your this red color line, that is rake face, if it is a straight line here then it will be negative. So, whether it is a positive, 0 or negative, your effective rake angle always in the negative part. So, that is the what is happening here in this case, and it causes the necessary compressive stresses to enable plastic deformation to occur in front of the cutting edge. So, this is our cutting edge. So, this whole thing behave as a cutting. So, wherever your uncut chip thickness is coming into contact and then it is leaving the machine surface. So, this whole part will behave as a cutting edge, right. So, now we consider that we are not considering our tool as a sharp tool, and because of that reason you are getting a compressive stress region in this particular location, that is in front of the cutting edge. So, this particular compressive stress distribution in the plastic deformation zone, it will deform the material, and then this particular ratio between the uncut chip thickness and Rn will decide that which is going to happen, what thing is going to happen here, whether it will remove as a chip, whether it whole thing will just compressed through this machine surface, or some part will go as a chip and some part as a compressive or the compacted material in the machine surface. So, this cannot be neglected. Let it be even smaller depending on the radius of the cutting edge and the uncut chip thickness, but some material or some part will be plowed in the later stage. So, we have to optimize our machining parameter, that is speed, feed and the depth of cut in relation with the uncut chip thickness and the cutting edge radius to get the efficient material removal. Now, fourth phenomena is the rubbing. Now, rubbing is by word only we can understand what does it mean. That rubbing means that when you rub two surfaces, with each other, that is called rubbing, and there is no any type of material removal. So, now let us see that how we can see this thing in the machining zone. So, now again you consider your alpha is even much larger than the earlier case. Now, this is your alpha, and now what is happening in the rubbing? The material deformation transforms into rubbing mechanism at a very high difference between the uncut chip thickness and the cutting edge radius. This is our cutting edge radius, and this is our uncut chip thickness, correct. So, now what is happening in this particular case, that now HC is very very small, and we are considering this R point, it is further located towards the flank surface, not to the rack surface, right. So, now if it is located here, now what is happening, your tool is moving in this direction, no material is located on this particular edge. So, there is a chance that most of the material will be compressed only, there will not be any type of material removal in this particular location. So, your material deformation it transfer into the rubbing mechanism. Rubbing mechanism, that means you are just rubbing the two surface. One surface is the tool surface and another surface is the workpiece surface, and whole thing will be moved as a elastic plastic deformation of this particular part. Now, the cutting tool rubs along the workpiece surface, that is what is happening at this particular location. Right. So, this is the location at which the rubbing is happening, and significant frictional forces are high, because now when you rub the surface, if you cut the surface, then at that time your frictional force will be very very less compared to this particular rubbing is the, because now there is a two surfaces which are no any sharp edges or anything, and you are just rubbing with the normal force. So, at that time your frictional forces will be very very high, and it consumes enormous amount of energy, because here it is elastic plastic deformation. So, no material is removed in terms of chip. So, material is just getting compressed, and finally it will become a part of the machine surface. So, that is the reason for the high energy of the machining process. So, this thing is also not important. So, here what is happening, said suppose in some cases external cases that where there is no chip formation initially, but what is happening in this case, that suppose you continue in this rubbing phase, that you continue, even you know sometimes do not know that what is happening at this location, and you continue the machining operation considering or expecting that material is removing and you are getting the cutting, but actually the operation is being processed is the rubbing process. So, if you continue in this particular cases, initially you will not get any chip removal, but what happens that later on if you continue with this particular case, so there is one particular, now see this particular region will be highly compressed in this case, and because of this rubbing, now your tool surface is in the tool motion is in this direction, and your workpiece material is coming from this direction. So, later on if in continuing operation, it will create some type of extra material here, and then what is going to happen, that it will continue to grow this particular region, this particular rubbing region. And if you continue this growing of this particular thing, at one particular instant what will happen, the size of this particular thing is so high that it will move as a chip, but that will happen in a rare case and in sometimes after a long time, but most of the times you have already consumed most of the energy in this deformation without any removal, and that is not the correct thing for making this particular thing. So, it get accumulated at this particular location and approaches to a minimum chip thickness value which is required to form a chip, and once it will reach this particular location, you can remove the material by a moving tool in this particular case. So, what is the conclusion of this rubbing step? That rubbing deteriorates the surface quality significantly. So, you should avoid the formation of the rubbing or reaching to this rubbing location in terms of making one particular decision about the cutting edge radius and the uncut chip thickness. So, let me stop from this particular slide. We will continue from the next slide in the next class. Thank you very much.